Alright guys, we are working now on the second part of this video, which is tangent graphs. So I want to first remind you right here, what is tangent? How do we find tangent? Well, tangent, when you were working in your unit circle here was, well, tangent would be opposite, soka opposite, which would be your y value, over the adjacent, which is the x value. And if you recall, the y value was actually your sine function for that angle, and x is cosine for that angle. So if we want to find tangent, we just have to take the ratio of sine to cosine. So let's look at some really kind of key values. And I know this is really small. I'm real sorry. Hopefully you can read it on your own paper here. Well, right here at this point, it would be at 0, it would be our y value is 1 divided by, it would be 0 divided by 1, which gives you 0. Let's look up here at, over here at pi. It's kind of the same thing, right? It would be -1 divided by 0, which gives you 0. And then same thing, 2 pi over here is the same thing as 0 degrees, so also 0. Now let's think about right here at pi over 2. So we're looking right here, pi over 2. Well, you'd have 1 divided by 0, 1 being the y value, 0 being the x value. 1 divided by 0, well, that is undefined. You cannot divide by 0. And similarly, down here at 3 pi over 2, it would be -1 divided by 0. So there, it is also undefined. And I love this. These 45-degree angles, do you remember here? They're like same. It's the square root of 2 over 2 for both sine and for cosine. So these are really nice because the result in dividing is just 1. In this quadrant, it's the same. Positive square root of 2 divided by positive square root of 2, and that's 1. 3 pi over 4, that's going to be right over here. 3 pi over 4, well, it's going to be negative divided by positive, so we're looking at -1. 5 pi over 4, that's right here, 225 degrees. That's going to be negative divided by negative, which will be positive. And lastly, we'll have a negative divided by a positive, which will give us -1. And I went through the process of completing this table so that now we can graph our tangent function on the back side. I'm going to keep a copy of this right here so we can look back at it. How are we doing? There we go. So now we're going to transfer these points onto our tangent graph here. So let's begin. At 0, it is 0. At pi, it's also 0. And at 2 pi, it's 0. And we can go ahead and reflect these values back over here. So at -pi, it would be 0. And at 2 pi, it would be that as well. At pi over 4, it'll be 1, which is right here. At 3 pi over 4, where's that at? Right here, it's -1. But here, at pi over 2, I shouldn't have skipped that, I'm sorry. At pi over 2, it is undefined. What is happening there is something called an asymptote. And it similarly happens at 3 pi over 2. Right here at 5 pi over 4, it's 1. And at 7 pi over 4, that's going to be right here, it is -1. And we can reflect this. Okay, so here at here's what that graph kind of looks like. Pi over 2, I'm sorry, at negative pi over 2, you are going to have an asymptote. And also at 3 pi over 2. And here's what's happening with our graph. You're going to be approaching those asymptotes. And your tangent graph is not this nice continuous curve. It's going to go right through there. It's actually this graph that's broken up into all these little pieces. So that one would look like this, and up here it would be going just like that. So that is our tangent function graph. It is pretty easy to distinguish. It looks a lot different from our sine and cosine graphs. So with that now, let me get that out of the way, move it on up. Notice the new repetition. It happens every pi. So our tangent graph, the period right here is pi. And you would divide that by your b value if it was different in our standard equation. Now, here's something really cool. This a value, it tells you your halfway point to your vertical asymptote. So in this case, our a value is 1, and so halfway to our asymptote from our intercept, I would be at that height. So we would put H-E-I-G-H-T, that is the height, halfway to the asymptote. All right. So why don't we try and graph one, and then we will be done. Sorry, my mouse was on the screen. That's embarrassing. Okay, so what is happening here? Well, first thing we would want to do is figure out the period. The period would be pi divided by our b value. Our b value here is 2. So our period is pi over 2. And our phase shift, well, to understand our phase shift, we kind of need to separate it out like it is done here. So let's factor out our b value. So this would be rewritten as 1/2 tangent to, it would be x, these would cancel out, and then it would be minus pi over 2. There we have it. I'm going to get my pencil ready because I know on this graph I'm going to want to use pencil in case we make a small mistake. So our phase shift is going to be pi over 2, and it's opposite of what you see here, so that would be to the right. It is negative in our equation, so I'm going to move in a positive direction, which is to the right. All right, we are going to go ahead and plot what it would typically look like. We would typically have our intercept right here at 0. And then because my period is only pi over 2 long, that's going to move my axis of symmetry. I'm going to have to shorten that up. It's only going to be halfway. So now my axis of symmetry is no longer at pi over 2, but at pi over 4. So that is going to take and cut this in half. And I would have another axis of symmetry right here and here and here. All right, and I'll continue over here in just a little bit. Okay, so what else is going to happen here? What else is going to happen? If we move it pi over 2, this is really fascinating. Look what happens. If I move it pi over 2, really everything just gets moved over into the next section. So that is really nifty for this tangent graph because it's just moving it into the next cycle. One cycle is pi over 2, and if we move it pi over 2, we're really just moving it in to our next cycle. So let me finish this up here. All right, and why don't we go ahead and plot what our a value tells us. The height halfway to our intercept is going to be at 1/2. So that'll be right there, halfway at 1/2, halfway at 1/2. So that would look something like this. All right, and I know that it's going to be kind of hard to graph these, and I don't expect it to be absolutely perfect. I'm just kind of looking for your asymptotes to be placed correctly, for your intercepts to be done accurately, and I'm going to be looking that you have used your a value to give you the appropriate height when you're halfway there. All right, so that's going to be right there, there, and there. Halfway, halfway, boom, boom, boom. And just a couple more here. And there you have it. That would be your translated tangent graph. Ladies and gentlemen, that is all that I have for you guys. We will work through these together because they're going to take a little bit of practice, but I know you're going to do well. Thanks. Bye.